hopefully you can see where we're going with this. We're now going to stick a server, because Kyle wants a server. We're going to stick a server over here, right? And this server we're going to connect to an Ethernet port on this router. So I'm going to go to my connections. I'm going to scroll back over. And once again, it's a direct connection from the server to the Ethernet port on the router. So we're going to need a crossover cable, the dotted cable. So click that. Click here, fast Ethernet. Go right here. We'll go to the first Ethernet port available, right? So now we've got a connection from here to the Ethernet, and we're going to have to configure it, right? Now, to do this, I'm going to do it a little bit like I did the PCs. I'm going to decide, first of all, what's this guy's IP address going to be in this label? It's actually not a configuration, it's just a label. And I'll say that this guy is another private address, 172.16. We'll say 1.100. Okay? 172.16.1.100. That's a private address. Okay? And now we'll go in and we will configure him. So we'll go in, configure him. Actually, I'll go to the desktop again. IP configuration. 172.16.1.100. Subnet mask. Gateway. 172.16.0.1. Now look at this. This is interesting. This is interesting. This guy's IP address, 172.16.1.100, but the subnet mask is classful when I clicked in here. It's class B, so 255.255.0.0. So it's the 172.16.0.0 network. The first address in the 172.16.0.0 network would be 0.1. So I put the gateway as 0.1. Okay? So that's different. Notice he's 1.100. But that's fine. They're still on the same network because the prefix here is 255.255. So all they have to do is share the first two octets to be in the same network. Okay. So I'll close that. That's configured. And now all we have to do is configure the router. So go to the router. Once again, we're not going to do command line. We're just going to do configure window, tab, fast Ethernet 0, the first fast Ethernet, IP address 172.16.0.1, classful subnet mask, and turn it on. Now we have green lights. Let's test to see if we can ping our gateway. Right? Command prompt, ping 72.16.0.1. Hit enter. You can see that I can ping him. Right? IP config. Let's verify our address. There it is, 1.100, and our gateway is 0.100. It's all good, right? Okay. All right. Now, here's the test. Can PC 1.100 ping the server over here? Can the PC ping the server? And the answer, right? Even though this guy can ping here, and this guy can ping here, and this router knows about these three networks, right? The ping will not work. So I'll just show you that it's not going to work. I'll run the command prompt, ping 172.16.1.100, destination host unreachable. Okay? Cannot ping from here to here, right? And the reason is this router knows about this network and this network and this network, but this router does not know about this network. This is an unknown network to this router. Now this router, it's got two routes in its routing table. It's got this network and it's got this network, but it doesn't know about this network or this network. Okay, so once again, this router knows about these three networks, 1, 2, and 3, and this router only knows about two networks. It's two connected networks. Just to prove the point, I'm going to go to the command line interface. I'm going to Control-C to exit out, or just type exit, hit enter, right? Get to the privileged exec prompt and do a show IP route command to look at my routing table, and you can see it knows about the 10 network, which is connected in between the two routers, and it knows about the 172.16.0.0 network. Notice it was able to take that subnet mask and basically combine it with the IP address to get the correct network. Notice the /16 because it's 255.255.0.0, and notice this one is /8 because it's 255.0.0.0 subnet mask. So anyway, it knows about two networks. So if this server, let's say, wants to ping one of these guys, it pings it, it sends to the default gateway, and it gets to this router. The router says, I don't know where there's a 192.168.5 network. I don't know where there's a 192.168.1 network. So this router will drop the packets. And the other way, if this computer right here, 1.100, tries to ping the 172.16.1.100 server, right? Its ping gets sent to its default gateway, right? First of all, it's trying to ping a 172.16 network. This router doesn't know where 172.16 is, so it sends it to its default gateway. So it gets to the router, and the router says, well, I know where 192.168.1 network is, I know where the 192.168.5 network is, and I know where the 10 network is. Right in between here, this is the 10 network, right? I'll just put that in there right there. Right in between these two routers is the 10.0.0.0/8 network. In between these two routers, but it doesn't know where 172.16 is. So this router drops the packet, right? And that's the scenario. Well, think about it. This PC, if it wants to talk to anybody outside of its own network, it needs a default gateway. Well, the router, similarly, it needs to have some type of route either on how to get to the 172.16 network, or it needs its own default gateway. In other words, the router needs a default gateway. If this router has a default gateway, it'll know, hey, I should send that this way, right? And that's what we're going to need if we want to ping or communicate all the way from this PC to this server over here. We're going to need to give this router either a static route to the 172.16 network, or a default gateway, or a gateway of last resort. It's called the gateway of last resort on how to get there.